Okay, here is Unit 4, Lesson 1. We're going to talk about rate of change. So our first learning target, I can find the rate of change between two data points. And the second learning target, I can put my answer in the context of the problem. So that just means describing it in real life, what's going on. So the rate of change allows you to see the relationship between two different quantities that are both changing. So in a line, the rate of change is going to stay the same. It's going to stay constant. Okay, so if we're going to write the rate of change, it's a ratio between these two. And we're going to say that the top, and think of this as a division bar. I'm going to think of it that way. So on top, we put the change in y, or the vertical change. And then that is compared, or that's over the change in x, or the horizontal change. We actually write this as a ratio, a number compared to another number. So if it's a 2-to-1 ratio, that means the y is going up 2 for every one time the x goes up. And so on. We'll see a few more of these. There's a few different ways you can do this. So the first way is when we're finding the rate of change from a graph. From a graph. Okay, so looking at this graph here, I'm going to put 3 points. Sorry, I'm trying to line my camera up here. I'm going to put 3 points here. I'm going to put a point right here, a point right here, and a point right here. Basically, I just picked corners. Like this one would not be a very good one because it's not on the corner of a square, but this is on a corner, that's on a corner, and so on. So from point 1 to point 2, how much does the y change? So just going up and down, here's 1, there's 2. That's a difference of 1 unit. So the y changed, 1 unit, one square on the graph. Now, what is that in terms of the label here? Again, this is cost in dollars. That's actually only a 50-cent increase. Okay, so the 50 cents, it went up. I'll say half a dollar or 50 cents. Now going left and right, I was here, now I'm here, just that's a difference of 2 units. So it went up 2, and the units on this is ounces. Okay, so what is the rate of change? Well, we would write that as 0.5 over 2, and if you divide that, it becomes 0.25. Okay, so what does that mean? What is 0.25? Okay, so that'd be $0.25 per ounce. Okay, so $0.25 per ounce. Or in other words, every time ounces go up by 1, your cost is going to go up 25 cents. Okay, so 25. So for each additional ounce, the cost increases 25 cents. Okay, so look at now, how much does the y from 0.2 to 0.3, how much does the y change? So look at the graph, how much does the y change? Okay, now it goes from here to here. Again, the level, think of maybe water rising, it went from here to here. Okay, it's a difference of 0.5. So up $0.5. And how much does the x change? Okay, so on this one, it's going up 2 ounces again. Notice it's the exact same thing. The rate of change then would be 0.5 divided by 2, which equals $0.25 per ounce. Okay, same thing as over here. I forgot to put per ounce. Okay, so the rate of change is 0.25 per ounce. How does it compare to the rate of change from 0.1 to 0.2? It's the same. And that will always be true because it's a straight line. So the rate of change will stay constant if it's a straight line. That's what we said up here. It'll stay constant. It should be the same answer every time. Okay, looking down here at a tank of gas, we've got the fuel in the tank, miles driven. So it makes sense that as you drive, that you'd be using fuel, and the fuel in the tank will be going down. So pick 2 points on the graph, and I'm trying to look for nice neat corners. Okay, here looks like it's on a corner, and the only other corner I see is this one. So using those points, how much does the y change? So here it's at 15, there it's at 5. Okay, so that's down 10 gallons. And then how much did the x change between those two? So from the first point here, it's at 0. Here it's at, that'd be 150 because it's between 100 and 200. So it would be, this one was up 150 miles, went from 0 to 150, so it increased. So what's the rate of change? Well, I'm going to write those on top of each other. Again, down means negative, so down 10 over 150. And so that, you could do some reducing there. If you want to divide it, or we leave it, we could just reduce it. It'd be negative 1 over 15. So what does that mean in this situation? Well, for every 1 gallon used, so every time, so how do we want to say this? So for every gallon used, the car traveled traveled 15 miles. And some of you may know that better, or make more sense to say that it's 15 miles per gallon. You know, that's kind of everyday speech. We'd say 15 miles per gallon. So if you want to write it that way, that would also be if you have the option of writing what you want, I would say the car gets 15 miles to the gallon. Okay, so let's turn this guy over now. Not fold as easily as I thought it would. It took longer than it should have to fold that. So find the rate of change from a table. So I'm going to give you a couple tables here. Okay, so looking at this, look at how think of this as your x and this is your y. So as the number of tickets looks like it's increasing here, what's y doing? Okay, so here it went up by 2, and then it went up by 3, and then it went up by 1. How is the y's responding? So is there a constant rate of change? Well, when this went up by 2, this went up by 30. Now if we write that as a ratio, it'd be 30 over 2. So 30 over 2, which is 15. When it went up 3, this went up 45. So is 30 over 2 the same as 45 over 3? And this guy, when this went up by 1, that went up by 15. So 15 to 1 ratio. So is this a true statement? Do all of these equal the same number? Well, 30 over 2 is 15, 45 over 3 is 15, and 15 over 1 is 15. So is there a constant rate of change? Yes. What is that rate of change? Well, it's 15. 15 over 1. What does it mean in context of the problem? Well, each additional ticket costs $15. Okay, so each additional ticket costs $15. Okay, look at the next one now. So time and then distance ran. So here's my time. Time increased 5 seconds. My distance ran increased 20 seconds. So think of that as a ratio, a 20 to 5 ratio. And always put your y's on top. Does that equal, this would be a 3 increase, this would be a 10. So this would be 10 over 3. Now, does 20 over 5, which is 4, equal the same thing as 10 divided by 3? No, that's 3 1/3. This is not consistent. They're not the same. So, no. Is there a constant rate of change? No. So what is it? No, it doesn't have one, so I don't have to answer that question. And what does it mean in this problem? I'm not going to answer that because we can't. Okay. So now, moving on, find the rate of change from a situation. So we're just given a story problem, basically, and that's a situation. So the baby giraffe was 70 inches tall at birth and 103 inches tall after 3 years. So what are my two data points? Well, at birth, so when you're born, your age is 0. His height was 70. And then 3 years later, height was 103. So this, what is the rate of change? Okay, so think about how did the y's change? Okay, because on the front side we talked that this is the change in the y over the change in the x. Okay, so change in the y over the change in the x. How did the y's change here? So it went from 70 to 103. That's an increase of 33. How did the x's change? Well, it went from 0 to 3. That's an increase of 3. Okay. Now, since we have two data points, we're assuming it's constant. We have no reason to believe it's not constant. So that would be 11. So what is the rate of change? 11. What does it mean in this problem? The giraffe, if I can spell this right, grows 11 inches per year. Okay. Next one. After 3 days, so 3 days later, after 3 days after something, the farmer had collected 38 total eggs. So in those 3 days, he collected 38 total eggs. After 7 days, okay, and we're just assuming this is from the same starting point. So maybe, you know, this was the beginning of the month, 3 days later, and then this is 7 days after the beginning of the month. So they're from the same reference point. He had collected 197 eggs. So what are the data points? Well, after 3 days, he had 38. After 7 days, he had 194. Okay, so what is the rate of change? Again, the rate of change is the y's, the change in the y over the change in the x. So change in y over change in x. Well, it went from 38 to 194. Okay, that's an increase of 156. The days went from 3 to 7. That's an increase of 4. Okay, so if we divide those, that's 39. What does that mean in the problem? So that means that the farmer collects 39 eggs per day.